Hey there, my name is Priyansh Nayak, and today I'll be guiding you on a walkthrough of my MIPS single cycle datapath virtual reality experience. We'll be beginning by working our way through the learning mode, and let's select an instruction from my catalog. Let's pick sub for our first instruction and start the lesson. The first phase is instruction fetch phase. It requires us to grab the instruction, fetch it if you will, and proceed to the instruction decode phase to unlock the next step. Once you get close enough, you can socket it in and it gets downloaded, and now we can progress through the instruction decode phase. Students will be supplied with all information about the various bits and what they stand for example the opcode, and also reference guides so they can make the correct decisions. In our case, sub is going to be the first choice, and since this is an R type instruction, we also need to select the funct bits, which is going to be the last option over here. Once that is done, we'll be required to put the relevant registers in their correct operands. As you may have noticed, I have all 32 registers set up that are commonly used by MIPS. The one we care about is T3 and T6. T3 is going to contain the value 40 and T6 has the value 70. We can locate them over here, so that's T3, we can grab it, as well as T6, let's grab it. We can make our way over here, so we can see that T3 goes to read register 1, that's the value 40, and T6 goes here, that's the value 70. These data packets, which are read data 1 as well as read data 2, basically contain the values 40 and 70 in it as 32 bits. Let's just proceed to the very next phase with these guys. Now comes the execution phase. This is a sub instruction, and here we need to choose the correct control signals. So instead of having this process be automated by the instruction decode phase, the students will be required to work their way through the various phases and do this themselves. They'll be provided with reference guides. For example, for the ALU op, we need to make a control choice. Let's select it to 2, which allows us to choose the correct function, which is the same from our instruction decode phase, subtract. In addition, there is the ALU source, which determines where the second input is going to be coming from. If I set it to 1, it's waiting for an immediate. So if I try to put read data 2 here, it's going to reject it. But if I set it to 0, also finality. These buttons, they can easily be selected using the grab button. And once it's all good, we can try executing the operation. There you go. This ALU result has successfully contained the value -30 in it. Since there's a sub instruction, we'll be skipping memory access for the sake of simplicity. Now, let us make our way to the write-back station. This is the final data path stage. It's going to require us to put this data inside of a register. So we're going to put this in the extension. This value doesn't come from a memory access, so we don't really have to turn that on. But it is a reg write. We actually have to write something, so we're going to trigger reg write on. Now you may notice that it's looking for T6, but we need to put it in T5 here. The reason for that is reg test. If it's set to 0, it's looking at RT, which was T6, so we need to set this to 1. And now it's correctly expecting us to put T5 here. So let us make our way back As you may have noticed, this panel has opened up as a nice shortcut. Let's just grab T5 here. We can make our way over here and deposit it. Since everything is correct, we can now execute right back. And now it contains the value minus 30, having consumed it from here. We can verify this by either looking at the register bank, which now contains negative 30 over here. And I also provide a sample register scanner around this corner that you can just drop your register on and see the value getting updated in real time. We can send this guy back by just pressing this. Finally, since we're done with our instruction, we need to tell the program counter to update itself and look to the next one. And that concludes the first lesson. Let's try doing this in practice mode instead. And I'm going to pick that. I'm not sure what this instruction is. Let's find out together. Practice mode is going to hide this so that we now will be responsible for decoding what this means. So let's make our way over there. And this time around, I'm going to turn off the navigational guidance for complete uncertainty. One thing to note is that the register bank gets reset between modes, so you will no longer see the changes. However, they exist safely in the same mode, that is. So let's make our way over here. Now we're going to be responsible for selecting the correct opcode as we learned during the previous mode. In our case, it's this. Oh, it's a branch not equals instruction. Interesting. So it's an I type. We are told to read the remaining bits from left to right. I'm going to use up a hint here, and it's going to tell me that RS is the first 5-bit register field after the opcode. So meaning it's going to be 0, 0, 1, 1, 0. I'm also aware that it uses a secondary register RT, a tertiary register. So I'm going to select the next bits 0, 0, 1, 1, 1. I could just try continuing, but it says I haven't selected the immediate yet. So here we are allowed you to ignore the leading zeros, and I can just put in 1, 0, 0. This information is also being told to the hints, which I have a limited amount of. If I do this correctly, I should be able to progress further. Now I also hide the exact register they need to pick. Instead, they need to get the correct number from them. So it says 6 and 7. We know it starts from 0, so it's gonna be these guys. If I accidentally put the wrong one, it's gonna reject it and consume one of my scanner attempts. I don't want to do that since I have limited amounts of those as well. There you go. A2 contains 12. That's a read data 1. A3 contains 16. That's a read data 2. So let's grab these guys. Now that we have them, we can continue. As instructed by the decode phase, we also get an immediate value over here. This immediate value is going to represent where we're going to be jumping. Let's leave it around here for a while and make our way to the execution phase. You may have seen that in the assessment mode, it's a little bit more braver and we have attempts. So if I just try to put these guys on, it accepts it correctly. But if I just try to execute right now, it says that it's pointing the wrong operation family. So I can use a hint. It's going to be very generous over here since you are expected to learn this during the learning mode. For example, the early operation in our case should be sub, since we're going to be comparing the values present in the two data packets. Instead of an ALU result, a branch operation produces a 0 result from the ALU instead. This is basically going to tell us if the comparison was a success or not. And since the subtraction, as you can see, 12 minus 16 is minus 4, we'll see what happens later on. Now, before I forget, I'm going to pick up the immediate on away, which is going to represent the target address that we might be jumping to if this is correct. And we do need to sign extend it since this is 16 bits. And there you go, the sign extended now. So let us make our way all the way to the final PC update station. Since this is a branch instruction, I'm going to have to update that. Now it tells us it's waiting for the immediate status. You can use up a hint. Oh, we still have to update the program counter. So, if we forget to do that, it won't take the correct address because it will try to compute the offset from the current instruction instead of where it should be doing that. So, let's place the immediate on the branch target. We do need to shift it left by 2 bits as required by branch instructions. And we can then place the 0 result to the check. Now what's the branch condition? Since we're looking at branch not equal specifically, that is where we're going to be leading to. Because as you remember, the two register values were in fact not equal. If I select equals, it will just take me to the next line of instruction. That's not where you want to go. You want to successfully execute it. So let's validate it. There we go. Now, let us proceed with test mode. This is going to take away all of our freedom and there's not going to be any sort of help that will be offered to the student. This is intended so to have them navigate the system themselves. For example, what happens if they fail here? I have just one chance. I know it's gonna be all zeros, but I'm just gonna type in gibberish for once. And that's immediately fails. There's no hints, no lesson guide, no references, just practice. I'm also just quickly gonna guide you through one of my other interesting instructions, store word specifically, that deals with memory access. Just to speed through it. So it wants S4, D6 and 12. S4 is containing the address. 12 is going to be the immediate offset that will be adding to it, and T6 is the value you want to store into it, 70. Now what do I mean by these addresses? Let's encoder them in a little bit. So first of all, I want S4 and T6. S4 goes here, T6 goes here, and the immediate packet which contains the hour offset is ready to be generated here. Obviously, never forget to sign extended, otherwise I'll show you what happens. Read data 1 goes to input 1 as asked. I turn the ALU source to 1, so I express an immediate, but it's not sign extended. Can't really do the computation because it needs to be the same amount of bits. So I do that. And then it's all happy. And since this needs to be an astral behavior, I can proceed. Now we have the ALU result, which is the newly calculated address of what value we want to update. And we also have that guy, which is the value we do want to put in. So let's proceed. As you can see, I had to make my way here, but this is blocked right now. Now, we want to update the data memory, which is represented here. You can hover over it and be able to see the addresses and values update what each of these words contain. So we have our address over here in the LE result. Let's plug that in. It's gonna point to that guy, which has the value 170 in it currently. We want to trigger a memwrite, and it's extracting the store packet. So here we go. Which has the value 70 in it. Once you execute the memory, that now contains the value 70 in it. Since we don't have a write back phase, it's gonna lead us directly to the PC update. But we can see this once we get to that particular word, that it has in fact been updated. And it will continue to be updated as throughout this learning mode across multiple instructions. That in essence is a simple overview of my entire lesson plan. I hope you enjoyed and learned something new, and feel free to give it a try. Thanks so much for watching. Bye bye.